So the problems on the first page are here, and what you needed to know in order to solve them is that if the sides are congruent, that means the angles here are congruent. So they give us one of the angles, so that means the other angle is the same expression, right? So if this is 2x, then the number of degrees in angle R is also 2x. And then we also need to know that the angles of a triangle add up to 180, which allows us to create this equation here. The 2x plus 40 is equal to 180, and we solve for x. And that's basically all of these problems here. And then this proof, what did we need to do? We needed to say that angle 2 is congruent to angle 3 by vertical angles. And then angle 1 is congruent to angle 3 from transitive property. And then finally, that AB is line segment AB is congruent to segment CB because of inverse isosceles triangle theorem, right? And then we get to the proof. So the next page here is an equilateral triangle. So it's a equilateral triangle. Has three congruent sides. The isosceles triangle theorem leads to two corollaries about equilateral triangles. First, that the triangle is equilateral only and only if it's equiangular as well, which means all the angles are the same. And each angle of an equilateral triangle measures to 60 degrees. Right? So an equilateral triangle is also equiangular, and each of those angles is 60 degrees. Okay, so let's see. So I guess you're supposed to complete these problems here. But yeah, let me do these two examples actually, and then you guys can complete the ones on the bottom. So it's proved that if a line is parallel to one side of an equilateral triangle, then it forms another equilateral triangle. Okay, so we have that these two lines are parallel. And how can we prove that? Then that means that this angle is congruent with that angle because they are corresponding. That if a line is parallel to one side, okay, so we're given that this is a equilateral triangle. All right, let's go ahead and do that. So statement 1 is going to be that PQ is parallel to BC. That's given. And also that triangle APQ is equilateral. So that's going to be given. And so since we know that this triangle is equilateral, then we can also say that it's also equiangular, and that each of the measures equals to 60 degrees. So we know that angle 1 and angle 2 are congruent. Right? So number 2 is angle 1 is congruent to angle 2, and that's because equilateral triangles are equiangular. Oh, I don't know how to say that. Equilateral triangles are equiangular. Okay. And then we could say for statement 3 that angle 1 and angle B are congruent. Right? So angle 1 is congruent to angle B, and also angle 2 is congruent to angle C. Angle 2 congruent to angle C, and the reason for that would be corresponding angles. Corresponding angles congruent. Okay. And finally, we could say that triangle ABC is a... Oh, and then we got to say that angle A is 60 degrees. Yeah. Number 4, we say measure angle A is equal to 60 degrees. And the reason for that is that each angle in an equilateral triangle measures. I don't know how to say that. Angles of equilateral triangle are 60 degrees. And so finally we can say that angle B plus angle C, measure angle B plus measure angle C plus, oh my gosh, I need more space here. Maybe we could just end it and we could say that triangle ABC is equilateral. And the reason for that would be all angles measure 60 degrees. Now there's a step or two that I should have put in here, that measure angle B plus measure angle C plus measure angle A is equal to 180 degrees. And we also have that measure angle measure angle B is congruent to measure angle C because of transitive. Right, because of transitive. And then we could say that measure angle B and C are equal to 60 because measure angle A plus B plus C is equal to 180. Right? And then we could say that ABC is equilateral. Okay, let's see if I can get through this one with the space that I have. So we're given that ABC is equilateral, so that means, and also 1 and 2 are congruent. Okay, so let's do a statement. And then reasons. So number 1 is going to be triangle ABC is equilateral and angle 1 congruent angle 2, and that's given. So what's next? So because ABC is equilateral, that means angle A and B and C are congruent, because triangles are only equilateral if they're equiangular as well. So 2 is angle A is congruent to angle C, and then the reason for that is man, I wish there was an easier way to say this. Equilateral. Lateral means also equiangular. Okay. So we have angle A is congruent to angle C. And we're supposed to prove that ABD is congruent with CDB. And so how can we do that? Angle, side. Yes, so we can do angle, side. Okay. So then we can do segment DB is congruent with segment DB from reflexive property. And then lastly, we could say that triangle ADB congruent to ABD is congruent to angle CDB. No. We want to say that the triangles are congruent first. And this is because of angle, side. And now that we have the two triangles are congruent, then we could say that all of their parts are congruent, right? So then we could say angle ADB is congruent to angle CDB, which is what we're trying to prove. And the reason would be the definition of congruent triangles. All right, so we have two proofs there, and this to sum up, equilateral triangles, if they're equilateral, that means they're equiangular, and not only that, but it also means that each angle is 60 degrees, and so we're going to use that to solve these problems here, and I'll go over the answers in the next video.